We're on number 4 now on the very same handout we've been on. And number 4 deals with the, well, let me find it here. There we go. So 4 deals with drawing any rectangle that has a perimeter of 40 inches. So this is the problem that I asked you to participate in. And so we're going to draw any rectangle. Don't forget a square is a rectangle. So I was glad that somebody put the 10 by 10 by 10, right? That's a square, but a square is a rectangle. And we will call this X and Y. All right. And if the perimeter has to be 40, right, you'd probably notice that you could come up with many, many different examples as long as X plus Y equaled 20. Right? Because X plus Y would be half of the perimeter. So I started with the example 1 and 19. You could do 2 and 18, 3 and 17, 4 and 16, on and on and on until we have 10 and 10. So I was pleased with the participation that we got. So let me just share that screen. All right. And then what you should notice is that I can have the same perimeter. I can have a fixed area and yet very different areas. Okay, so notice the 10 by 10, that was the perfect square. We had the largest area, and 12 by 8 or 11 by 9, those are also close to being square-like, okay, and the area was very large. Now, I decided to draw a really long, skinny rectangle because I knew that wouldn't be the one that most people would think of. I also noticed that no one did 2 and 18, 3 and 17, 4 and 16. People tended to shy away from the longer, skinnier rectangles. But notice that this one had the smallest area. All right, and then the next smallest area on here, and so a lot of people had the same, the 15 by 5. Again, this is longer and skinnier compared to the rectangles over here that have, it's not as long and skinny as the one I did, the 19 by 1, but it is longer and skinnier compared to the more square-like rectangles, which end up having our largest area. All right, so instead of just doing this whole like try different examples and see which one gives us the largest area, let's see how we could actually write a formula in order to maximize the area of the rectangle. Okay, so this is what in the problem constrains me as far as being able to make my area as large as possible, because otherwise I'm trying to maximize my area. So I might say, well, how about I just make X and Y huge then? Then I'll get a huge area, right? But I'm constrained by the fact that I need X plus Y to be 20. All right, so that limits me as far as being able to make the sides just as big as I want. Now, notice that the area formula, we should know the area formula of a rectangle. Area equals length times width, which in this case is just X times Y. Okay, so there's the formula for area, and I want to maximize the area. All right, so in other words, I want to find a function, plug it in my calculator, right? Get something like this on my calculator screen, and find that maximum point. All right, but how do I plug X plus Y into my calculator? That won't work. All right, so we should know that to plug into our calculators, we have to have a function all in terms of one variable. So I'm staring at these two equations, wondering, how do I get a function that I can plug into my calculator? All right, the area is the one that I want to maximize. So that's the one I want to actually put in my calculator. So what I could do is I could take this equation that constrains me, and I could say, well, this is what Y is equal to if I solved for Y. All right, and then as I've said before, if you want to be a good mathematician, you just have to be a good substituter. So if I want a function that's all in terms of one variable rather than two variables, if I don't like the Y here, then I replace it with its equal. Okay, so its equal is, and actually I'm going to write this like this. So the area equals X times, so instead of Y, I'm going to put 20 minus X. And then I have area as a function of X. So I'm going to write it like this, A of X, area as a function of the variable X. The X represents this length of this side. The Y represents the length of the other side of the rectangle. When I go to graph this on my calculator though, when I type this into my calculator and this becomes the Y that goes into my calculator, on the calculator, the answer that I'm going to get is the area. Okay, it's not going to be the length of this side. So let's go to the calculator. Now, actually, before we go to the calculator though, we should always talk about the correct window. What are the possible values for X, right? I did an example where X was 1 and Y was 19, right? So X could be a value like 1. X can't be negative. X can't even be 0, right? But could X be like 0.1, right? It could, okay? It could be something very small like that. So I'm going to say that X is going to be between 0, because I know X can't be 0, but it's okay to set my window bigger than I know that I need. Now, what's the biggest value that I could have for X? Okay, X couldn't be 20 because that would make Y 0, but X could be 19.9, right? And that would make Y 0.1. Okay, so X can't be 20, but I could get up very close to 20. That would just make Y very small. Okay, so X has to be some value in between 0 and 20. So now that I've established that, I'm going to go to my graphing calculator. And I'm going to type in my equation. So X times 20 minus X. And I'm going to go to window. As I mentioned, I often will start in the standard window, but this time I have established that I need to have a range from 0 to 20. And then I use this beautiful feature, which is Zoom Fit. It will automatically adjust the Y to fit and show the critical features of the graph on the domain of 0 to 20. All right, and there's my graph. All right, I can see that when X is very small, like I used 1 for X, 1 and 19 for X and Y, I can see that gives me a very low area. All right, you guys that did the more square-like shapes, you're over here where you let X be 10 or 9 or 11, right? So you guys are in here, you're getting a much larger area. So let's actually find the maximum by doing second, calculate, find the max. And enter. And notice this would round off to 10 and the maximum area would be 100. All right, so the 1 or 2 people that had the 10 by 10 rectangle, the perfect square, you actually found the maximum area that I could create with that perimeter. So going back here and just finishing off the problem. So I got X equals 10. And Y is 10. The dimensions of the rectangle are 10, right? And then the max area. And did I use units? I did use units. I said inches. Okay, so I should label my answer with inches then. And so then the maximum area is 100 square inches. Okay, so far I've only worked with one equation before I got to this example. So the previous examples, I had one equation. All right, many times I'm going to end up with two equations, and we have names for the different equations that we're going to get. One is called the objective equation, one is called the constraint equation. And I was using the words here with this equation where I was talking about how the 20 constrained me, right? That prevented me from making X and Y as large as I wanted. And then my object, the objective of this problem was to find the maximum area. Okay, so this was my objective, right? To find area. So that's how we get these terms, objective equation and constraint equation. So the objective equation is the function for which you need to find the maximum or minimum. It's the objective of the problem. All right, then the constraint, just like it sounds, it relates the given constraints. Did I spell wrong in constraints? I didn't have my S. Constraints to all other variables in the problem. Okay, and then what I do for these problems when I have two equations is I solve the constraint equation for one variable. Okay, because the constraint has to work its way into my objective. So I solve for the constraint equation and then I substitute it into the objective equation. All right, the constraint has to work its way in to the function in which I need to find the maximum or minimum. Okay, once you've got the equation in terms of one variable, then you graph it and then you go from there. You either find your maximum or minimum. All right, so let's take a break.